4.1 moles of glucose and want to make a 0.25 molar solution with it, what will be the final volume of the solution? So here we're starting with 4.1 moles, and we want to use molarity to go to liters. We'll take the molarity of the solution, 0.25, 0.25 molar. Okay, as we did before, we got to turn this into a conversion factor by unpacking it. Okay, so what this means is that there are 0.25 moles per 1 liter. Pull this down. Is this going to work as a conversion factor? No, it's not, because I have moles up here and then also moles up here. So they're not going to cancel out, right? I need moles down here. Okay, so what I can do is I can take this conversion factor and flip it. And now I can have 1 liter on the top and 0.25 moles on the bottom. It's the same thing as this. It's just flipped around. And now when I pull this down here and I multiply, I'm all set because I got moles up here, moles down here. They cancel out. I'm left with liters, which is what I'm looking for because I'm looking for a volume. So the math here is going to be 4.1 times 1 divided by 0.25, which is going to give me, rounded to 2 significant figures, it's going to give me 16 liters. So all I had to do here was take the molar concentration, unpack it to get moles over liters, but then since that didn't work, I had to flip the conversion factor. You'll always have to unpack molarity. You may or may not have to flip the conversion factor to make it work. Now we're going to do some problems where we have to do a few more steps with some additional unit conversions. If a student has 35.0 grams of FeCl3, that's iron chloride, and needs to make a 1.5 molar solution with it, what will the volume of the solution be? Okay, so in this problem, we're looking for volume, so volume is going to be in liters. Molarity lets us convert between moles and liters, but check this out. The amount of iron chloride here isn't given in moles, it's given in grams. So before we can use molarity as a conversion factor to get liters, first we've got to take 35.0 grams and we've got to convert it to moles. How are we going to do that? We're going to do that by using the molar mass. So iron chloride is made of iron and 3 chlorines. So I do the molar mass of iron plus 3 times the molar mass of chlorine, and I get this number here, okay? Is this going to work as a conversion factor, grams over moles? No, it's not, because I got grams, grams there. So what I'm going to have to do is rewrite it as 1 mole divided by 162.20 grams. It's the same thing, just flipped. And now I can pull this up here, grams up, grams down, they cancel out, and I have moles here, and I can multiply through and get 0.216, 3 significant figures, moles. Okay, so now I know how many moles of iron chloride I have. So now I can go on to the next step where I'm going to use 0.216 moles and multiply that by molarity so that I can go from moles to liters, like right up here. Okay, now for the molarity, I've got to take what I start with, 1.5 molar, and I got to write that as a conversion factor. So I can write that as 1.5 moles divided by 1 liter. That's one way I can write it. Pull it up here, it's not going to work. Moles, moles there. Okay? So I can flip it, and I'll get 1 liter divided by 1.5 moles. And now I can move this up here for molarity, and it'll work. So I can cancel moles and moles, left with liters, and I get 0.14. That's rounded to 2 significant figures here. 0.14 liters. Okay, now this could be the final answer here, 0.14. But the thing about this is it's smaller than 1 liter. So it would be really nice to be able to write this as milliliters. Milliliters is a better unit to report small volumes in. Okay, so I can do one more step here, and I'll do 0.14 liters, and I'll find a conversion factor that I can use for this, okay? 1,000 milliliters in 1 liter, and so one of these is going to be good. It's either going to be this one or this one, liters on top, liters on the bottom here. So I'll just pull this conversion factor out, multiply by this, and now I have liters up here, liters down there, left with milliliters. All I'm going to do is 0.14 times 1,000, and that's going to give me 140 milliliters.